humans have 23 pairs of chromosomes, or probably it's more appropriate to say that there's 22 pairs and then we have 2 sex chromosomes. For a female, the symbol for female, females have 2 X chromosomes, whereas males have an X and a Y chromosome. So let's go ahead and do a Punnett square so I can demonstrate to you what is the chance of a offspring being male or female. So for the female up here and the female parent, the mother, can only offer either an X or an X. These are the 2 options for the chromosome that she can offer. And the male is either an X or a Y. Okay, so with meiosis, of course, we get the splitting of the chromosomes, the homologous chromosomes. So in half the father's sperm, they will have an X chromosome, and half there will be a Y chromosome. So you guessed it, it's actually the father that determines the sex of the child. Alright, so let's have a look at this Punnett square then. So this is the female and this is the male. So we've got an X and an X. So that offspring will be female. We have an X and an X. So that offspring will be female. We have an X and a Y. So that offspring will be male. And again, X and Y. So there's 50% chance of having an offspring that's female and 50% chance of having an offspring that is male. Another thing that's important here is that when we talk about sex-linked inheritance, we're really referring to the fact that there's genes on the X chromosome. On the Y chromosome is really just genes that express or the control male characteristics. But on the X chromosome, there is genes that control a number of different things. And also, interestingly, there's a number of diseases associated with the X chromosome. So, if we have a recessive disorder, for example, Deschenes muscular dystrophy. Deschenes muscular dystrophy is a very, very serious, life-limiting disorder. The children with Deschenes muscular dystrophy get significant weakness that's progressive and gets worse and worse and worse to the point where the child will actually die from Deschenes muscular dystrophy, often in their late teens or early 20s. So it's a very, very serious condition. Now, the gene that's associated with Deschenes muscular dystrophy is on the X chromosome. Now, and it's also recessive. It's a recessive disorder and it's on the X chromosome. So let's have a look. If we've got a female offspring, let's say, for example, the mother is a carrier of the gene. So we're just going to put a D up here for Deschenes muscular dystrophy. So the mother is a carrier. The father is normal, he's not affected at all. Now, so this is the allele that has the disorder. It's the recessive allele. So the mother, because she has a dominant, or she has an X chromosome that's unaffected, she will be a carrier, but she won't actually have the disorder herself. So she mates with this gentleman who doesn't have it, and let's see what happens. Okay, so the mother, one of the options is to have the allele that's got the affected gene with the father's X gene, X chromosome, and we see that this person will be a carrier. So this person is a female, and she will be a carrier because she will have one damaged gene or one disordered gene. This child here won't be a carrier and they won't be affected. This child here, the X chromosome that's inherited, is the one with the Deschenes muscular dystrophy gene. And importantly, whilst it's a recessive gene, this male child does not have another X chromosome with the dominant allele that's not diseased. And this is the important thing about sex-linked inheritance, is that when we have a recessive disorder on an X chromosome, it's always the males that suffer the condition because they don't have another X chromosome to compensate. So this child here will have Deschenes muscular dystrophy. This child here won't be a carrier and won't have the disease. So Deschenes is one of the classic conditions that's a sex-linked inheritance. Another one is haemophilia, and there's a few others as well.